All right, let's learn about empirical and molecular formulas. You're going to need a calculator and a periodic table. Grab one if you need one. All right, so there are two kinds of chemical formulas. You need to look at this graphic organizer and note one type of chemical formula is called an empirical formula. Empirical formulas have reduced subscripts. That's what makes it called an empirical formula. Molecular formulas are the actual chemical formula for a compound. Actual formulas might have reduced subscripts.
There's a group that meets in the
or may not.
conference room on Friday afternoons. You know who you are.
Can you hear Miss
Come
Bruner
now.
talking on the announcements? All right, anyway, here we go. So molecular may or may not be reduced. All right, so here's an example of what I'm talking about. Look at this chemical formula. So it says C6H12O6 is the molecular formula for glucose. What I'm saying is that's the actual formula for glucose. So when you look at this, is it an empirical formula? The answer is no. It's not, because these subscripts are not reduced, right? 6, 12, and 6. So if we reduce them, we can write the empirical formula for glucose. So what is the empirical formula for glucose? CH2O. Do you agree that that's the reduced form of C6H12O6? So empirical formulas are reduced. Molecular formulas are actual formulas. Sometimes they happen to be reduced, like carbon dioxide is a molecular formula. It happens to be reduced, so it also fits the empirical definition. All right, so what does this have to do with what we're doing in class? Well, one of my favorite shows is NCIS. Here's Abby. I think she's cool. So here's a scenario. Let's say an unknown chemical is found at a crime scene. Crime scene tech collects the sample, takes it back to the lab, and a chemist like Abby takes that sample and runs it through a machine called a mass spec. It's called a mass spectrometer, actually. And what the machine does is it analyzes the sample and it reports percent composition, right? Percent composition, what you learned to calculate the other day. So, mass spec analysis says that our sample is made up of carbon, hydrogen, and oxygen in these percents. The mass spec often will also give us the molar mass of the sample. So, we now know that this compound contains carbon, hydrogen, and oxygen, and that the formula would add up to this molar mass. But what is the compound? There are millions of compounds that have C's and H's and O's. Well, that's what we're going to learn to do. We're going to learn to convert these percents into subscripts. We're going to learn to come up with a subscript for C, and a subscript for H, and a subscript from O from those percents. So here's how it's done. We find a chemical formula this way. I've recopied the percentages here for you, same as on the last screen. And here in the green box, we're going to write some steps. I need to learn to find the empirical formula first. The reduced formula is found by taking the percent and changing it to grams. Over here in the box, I'm going to do that for each one of these. So I'm going to write down my 40.9% carbon, but I want to change the percent to grams. So watch how I do it. Instead of writing percent, I'm just going to write grams. Woo, that was tough. Watch for hydrogen. 4.58%. No, grams. I'm changing percent to grams. Boy, that's tough. 54.5%. No, change it to grams. So literally, I just write it as grams. Percent to gram. Then gram to mole. All right, so over here in the white, gram to mole. I'm going to set up our dimensional analysis. And we're going to look up carbon on the periodic table, and its molar mass is 12.01 grams in 1 mole. So that equals, we look up hydrogen, 1.01 grams in 1 mole equals, and Oxygen, 15.99 grams in 1 mole equals. All right, so we're going to type these calculations into your calculator. And when you write what it equals, you want to give your answer to at least 4 decimal places. And the last one, when we divide this, 3.4084. I have changed percent to gram, check, and gram to mole, check. Next step, divide by the smallest. So I look at these answers that I've gotten and I figure out which answer is the smallest. 3.4055 is smallest, so I divide all three answers by that number. All right, so when I put this in my calculator, clearly I will get 1. 4.53, when I divide this, I get 1.33. And this number, I'm going to get 1.0008. I think that's close enough to 1. So, divide by the smallest. Next step, multiply, X is for multiply until whole. Alright, so let's look at these answers I've gotten. 1, 1.33, and 1. Are they all whole numbers? No, 1.33 is not a whole number. Multiply till whole means that I'm going to find a number that I can multiply this by to equal a whole number. If I multiply this number by 2, I'll get 2.66. That's not a whole number. If I multiply by 3, though, I get 3.99. Guys, we're going to call that 4. Whatever I do to one of these, because I'm setting this up as a ratio, I have to do to all. So since I multiplied this number by 3, I multiply this one by 3. So I get a 3, a 4, and 1 times 3, I get another 3. These numbers become my subscripts. Percent to gram, gram to mole, divide by the smallest, multiply till whole, and here is my empirical formula. C, over here, carbon led me to 3, so C, 3. Hydrogen gave me a 4, and oxygen gave me a 3. So, I found my empirical formula. I used my percents, but I haven't used the molar mass yet. Well, here's the question. So, is this empirical formula that I've written, delete that for a second, is this empirical formula that I've written the actual formula for this compound? How can I tell? Well, if we add up this molar mass, it should equal the molar mass from our sample, right? So let's add. If I take 3 times carbon from the periodic table, right, molar mass, plus 4 times hydrogen, plus 3 times oxygen, if I add all that up, I get 88.04. The molar mass of my empirical formula is 88.04. Uh-oh, that doesn't equal 180. So this must not be the formula. That's not the actual formula for the substance. So one last step. What could I do to 88.04 to make it similar to 180? We multiply it by some whole number, kind of like what we did over here. So if I multiply 88.04 by 2, I get 176.08. That is pretty similar to 180. So this factor of 2 becomes a big deal. What that tells me is that my empirical formula is C3H4O3, but the actual formula, or the molecular formula, is C6H8O6, the actual formula. All right, one last example. Okay, let's look at this next page. I'm going to do kind of a summary on this page. I've given you new data here. All right, this new data is talking about a compound called nylon. So step 1 was to find the empirical formula. Remember, empirical, percent to gram, gram to mole, divided by the smallest, multiply till whole. You are responsible for learning that rhyme. So if we come over here and say 71.65 grams to mole. Okay, this was chlorine, so you look up chlorine on the table for 5 grams in 1 mole. All right, that's for chlorine. For carbon, we have 24.27 grams of carbon. Convert grams to moles. And for hydrogen, 4.07 grams of hydrogen. Convert grams to moles. Alright, so we put these in our calculators, and remember, you're going to want to record your answer to 4 decimal places. Alright, I get these 3 numbers. We have done percent to gram, gram to mole, divide by the smallest. So we look, the smallest number is this 2.0208, which will give us 1 when we divide. This number is going to give me very close to 1, so we're going to call it 1. And this number gives me 2. Divide by the smallest. Multiply till whole. So let's look at these numbers. They're already whole. I now have my empirical formula. Empirical formula is ClCH2. Great. But we want to check the actual formula. So, is this the actual formula for our compound, which I mistakenly said was nylon a few minutes ago? We're going to do that example in class. This is actually a gasoline additive that we have here. Okay, so molar mass, 98.96 grams. So add up a chlorine. Right, look on the periodic table. Chlorine, 35.45. Plus a carbon, 12.01. Plus 2 hydrogens. The molar mass of this compound, this empirical, is 49.48. So, to check for the actual formula, find the molar mass of the empirical. That's what we just did here. Does it match the given molar mass? Does it match 98? No. If not, then distribute a whole number. What could I multiply 48 by to make it equal 96? Whole number by 2. So we take our empirical formula and we distribute a 2 through it, making my molecular formula Cl, distribute the 2, Cl2, C2H4. Here's the actual formula for this gasoline additive. Alright, we'll solve more of these in class. So during the video, a teacher made an announcement over the loudspeaker. As you turn in this video, tell me the name of the beloved Spanish teacher who made an announcement on the loudspeaker during the video. See you in class.